In this one, we're going to talk about spirometry, which is the act of measuring the amount of air that comes and goes out of the lungs. The lungs are going to have a certain volume. There's a certain amount of air that can come in that they can hold. We're going to learn that the total volume of the lungs is 6,000 milliliters, or said another way, 6 liters. That's how much air can be put in it. But we're going to learn that it only holds close to that. Our body stops our ability to breathe in when we get close to 6 liters. Because remember, it's fragile tissue. We don't want to overinflate it. So the lungs are going to bring in air or push out air mainly by the diaphragm. The diaphragm is going to be the main muscle of respiration. So when the diaphragm pulls down, that's going to actually increase the volume that's in the thoracic cavity, and that's going to cause air to be pulled in. Remember that in everything, things move from high to low. So if I decrease the pressure in here, and since the pressure out in the normal air hasn't changed, that makes this high pressure compared to low pressure in here. So then air is pulled in from high to low. Well, I'm going to erase all of that stuff. It looks like a whole bunch of gibberish on there. But hopefully that makes sense. That's how our body is bringing air into the lungs. The diaphragm is the key. This is another picture that kind of shows that. The diaphragm, as it flattens out, that's going to increase the volume in the thoracic cavity. So air has to come in to fill that empty space, or to go from high to low, as I said. Now, on the opposite end of this, and there's not a good picture with it, but just imagine that instead of these arrows pointing down, the diaphragm goes back to normal. As that goes back to normal, this becomes the area of high pressure. And since this doesn't change, this ends up being low pressure. So air is going to be pushed out to the outside world. So that's how we breathe under normal conditions. Now we're going to recruit other muscles when we are breathing heavily or labored. And those muscles are going to be the ones that are in between the ribs, as it's kind of showing here. They're called intercostal muscles. If I want to breathe in more than normal, so I'm yawning, or I am doing something like that, or I'm getting ready to talk, so I take a big deep breath in, it is going to be my external intercostal muscles that are going to pull my ribs out. And a way to remember this is always keep in mind that muscles can only pull, they can't push. So if I have a rib here, and let's say this is my thoracic cavity on this side, and I'm wanting this rib to be pulled out, the muscle itself has to be outside of that, because it can only pull, it can't push. So if I want to increase my thoracic cavity, I need to pull my ribs out. So it is the external intercostal muscles that are going to do that. If I want to breathe air out forcefully, if I'm going to cough or sneeze, these ribs are going to be pulled in on both sides to squeeze this thoracic cavity. And since if I've got a rib here and I need it, and again the thoracic cavity is here and I want it to be pulled inward, that means that the muscle has to be on this side. So it is the internal intercostal muscles that are used to forcefully exhale. So again, if you're going to sneeze or cough or something, it is the internal intercostal muscles that are going to be doing that. Now, in spirometry, when we're measuring normal flow in normal air coming in and out, what we're looking at is to compare normal with abnormal, and then we can figure out about disease processes, whether it is obstructive or restrictive. There's basically two categories of respiratory diseases, obstructive versus restrictive. This is in your student handouts as well, so make sure this is a lot of words, so make sure that it's you know where it is. Obstructive is a flow problem. These are things that I'm going to have a hard time getting air out. Things are going to block my passageways. And it's going to make it to where it's hard to breathe out. Obstructive air diseases are where we have a problem breathing out in general. And there's a lot of commercials now, and I don't know, now that I'm older, so I watch things like Jeopardy and Wheel of Fortune, which I guess a lot of people might not. So they're always medical commercials, medicine and whatever. And one of them is always about this guy that has asthma and he can't breathe out. Or emphysema, I think it was, and he can't breathe out, and his kids want him to blow the candles out on his birthday cake, and he's actually talking about the big bad wolf and the three bears, and he huffs and he puffs and he can't blow anything out because he has an obstructive respiratory disease, which again is a flow problem. Things are obstructing the flow. Now on the other side, we have what is called restrictive respiratory diseases. These are going to be volume problems where our volumes are reduced, right? So we're going to talk about volumes in just a minute, but basically understand what it's saying is I've got my lungs, all right, and again, terrible drawing here, but when I breathe in, they try to push out, right? And so if I have something like a long time ago, and if you women wear these now, I am so sorry, but I know a long time ago they used to wear corsets where you would wrap something around you and it would have this little thing in the back and you'd have somebody lace it up and pull it and they would squeeze. And it was hard to breathe when you had those on because it restricted your ability to breathe air in. And that's exactly the same as what restrictive diseases are. And so these things are going to kind of stop the process of being able to expand the lungs. So that's why it's considered a volume issue. Now this gives a list of both, the ones for obstructive and the ones for restrictive. I'm not worried about that. What I really want you to know is obstructive is a flow problem, and it is going to have a problem breathing out, where restrictive is a volume problem, and it's just the fact that it is going to have a limited amount of stretch, so I can't bring as much air in. So now we want to look at a couple of the volumes. This is the respiratory capacities and volumes that the book has in it. I'm going to use one a little different. I think it's a little easier to see while the numbers, some of the numbers are a little bit different. I'm not worried about the numbers. I'll tell you the numbers that you need to know, and they're pretty straightforward. This chart, I think, does a better job of breaking these up. And there's a dividing line. This side is going to be what are called lung volumes, and there are 4 lung volumes. All right. And then this side are called capacities. And this is where I take the volumes and combine them to get a better understanding of what's going on. And again, there's going to be 4 of these. Now, the only ones I'm going to want you to know the actual numbers on are going to be, I want you to know this one, which is called tidal volume, and we'll look at that in a second. And then I also want you to know total lung capacity. Total lung capacity is 6,000 milliliters, like we had said earlier. Tidal volume is going to be 500 milliliters. Now let me erase my scribble here and start off on explaining what each of these are. All right, so while we look at this, the first one and the most important thing really, because these are the primers, are the volumes. And there's 4 lung volumes. Remember that total lung volume is 6,000 milliliters. So if I was to breathe in as much as I can, I'd get close to that. My body will shut it down before I get there, but it'll get close to 6,000 milliliters. But we don't do that all the time. You don't breathe in all you can and breathe out all you can every time. As a matter of fact, we're going to have a little area that is our normal breathing. This little volume is called tidal volume. And it is called tidal volume, the same reason why we call the things out at the beach tides. Tide simply means to come and go, back and forth. And so in tidal volume, we are going to have where we breathe in and then we breathe out. Breathe in and breathe out over and over again. And that's what our tidal volume is. Now, with that, the tidal volume is 500 milliliters. Now, obviously, we do not use all of the air in the space in our lungs. When we breathe in normally and then start to breathe out, we're going to have an area of empty space in our lungs that we have available for us to use. It is called the inspiratory, right, breathing in, reserve, holding it in case we need it, volume. That is what the name of it is, the inspiratory reserve volume. You don't need to know the number on it for me at this point, but you do need to know that at the top of a normal breath, so I'm sitting here talking and I'm breathing in and out, tidal volume, and then all of a sudden something happens and I need to breathe in. I tap into my inspiratory reserve volume. Now, just like I have an inspiratory reserve volume at the bottom of a normal breath, so when I breathe out normally and I'm just about to breathe back in, there is an amount of air that is in my lungs. Some of it I can use and some of it I can't. All right? Now, that is divided up into two sections. The part that I can use is called the expiratory, breathe out, reserve, left over to use in case I need it, volume. The expiratory reserve volume is the amount of air that's going to be in my lungs at the bottom of a normal breath. So if I'm breathing normally and then something happens and I get some pepper in my face or pollen and I sneeze, I'm going to use the air in the expiratory reserve to blow that out. If I cough or whatever, that is the expiratory reserve that I'm going to be using to kind of, again, blow air out. So I have two reserve tanks. I've got normal breathing, which is called tidal volume, and you do need to know that that is 500 milliliters. And then I have empty space that I can use above it called inspiratory reserve, and I've got air that's left over below a normal breath that's called expiratory reserve. So I've got two reserve tanks, basically. Then I'm going to have an amount of air that will never be able to be blown out of my lungs. All right. This is air that's going to be found in the bronchioles and in the trachea, all these areas that can't collapse. So if you blew out as much as you could, get all of the air out. If you get all of the air out, there's still going to be an amount of air you'll never get out of there. Unless you get run over by a steamroller, and then you got bigger issues. Now, the residual volume is what it's called. Understand residual. So if you've got kids and you let them wash your dishes at home, you'll find out pretty quickly that a lot of times they're pretty bad at it. And they leave stuff left over, and it's called residue. Residue and residual are words that mean leftover. So that's what's going on with this. The residual volume is going to be the leftover air. Kind of like all the little drop of juice at the bottom of one of those Capri Suns or a juice box where you're trying to get it and you just can't. There's going to be an amount of air that you can't get out of the lungs. It's leftover. So it's called residual. So these are the four lung volumes. I've got inspiratory reserve, the area that I've got just in case I need to breathe in more than normal. I've got my normal breathing, which is called tidal. And again, you need to know that that's 500 milliliters. And then at the bottom of a normal breath, I have some air that's left over that I can use, and that's called expiratory reserve volume. And then finally, the amount of air that will never be able to be blown out of my lungs, which is called the residual volume. And it's just the air that's trapped in the piping. So the next thing we look at is how we combine these. So we're going to combine these into things that we call lung capacities. So first of all, the total lung capacity, which is straightforward. It's all four of the lung volumes added together, and comes up to 6,000 milliliters. That is the total lung capacity. It's pretty self-explanatory. The next one, that's also a fairly easy one, hopefully, is called the vital capacity. Now think about this. The word vital means life. All right, so if you're taking vital signs, they're signs of life. All right, vital capacity means the capacity of things, the addition of these volumes that we can use for life. And as you can see, there's only one that we can't use for life, and that is this residual volume. So the vital capacity is simply adding together the three volumes that we can use. All three of these we can use for life. This is kind of interesting trying to write with this little marker, but hopefully you see what I'm saying. Vital capacity is going to be my normal breathing plus my 2 reserve tanks. So then we get to the last two, and these are the ones that end up kind of giving people problems. Now, what I want you to understand is, and I'm going to try and highlight this little bar right here. The bottom part, I'm all over the place. The bottom part of a tidal volume. This is a dividing line in the lung. So one respiratory cycle is simply the breathing in, coming in, and then breathing out. Once I stop and start to breathe back up, I'm starting a new respiratory cycle. So the baseline, again, is this little line here. And I'm going to try and do a better job of drawing that because I think I got it all over the place. But this line right here is going to be a dividing line between the normal breathing and the one respiratory cycle and the next. And so that's where this line is. So I divide the lung, the last two capacities are dividing the lung between those two. So if I'm looking at this and I start another respiratory cycle, right, before I start to breathe back down, if I was to try and keep breathing up, I would get up to the top where I cannot breathe anymore. And this ends up being called the inspiratory capacity. Capacity is, again, how much I can do. How much can I breathe in? So it's going to count the breathing in of the tidal volume plus the breathing in of my inspiratory reserve. So it is called the inspiratory capacity. All right, so the inspiratory capacity is going to be the addition of both the tidal volume plus the inspiratory reserve. Most people get that one pretty well. The last capacity is one that throws people off. It is called the functional residual capacity. All right, we just said residual means leftover. So at the bottom of a normal breath, what it's saying is this: at the bottom of a normal functioning breath, how much air do I have left over? And so I'm going to have my expiratory reserve plus my residual volume. So this little area at the bottom of a normal breath is called the functional residual capacity. Now, these are kind of tough, I get it, but I don't want you to try to memorize this. Try to understand why they're named that, because if you do, it's pretty easy to put these together like little Legos. All right, so we've got reserves, we've got the volumes on one side and capacities on the other. The volumes, there are 4 of them. I've got normal breathing, which is tidal volume, and my 2 reserve tanks on either side, inspiratory and expiratory, and then I have what's called the residual volume, the air I'll never breathe out. To combine them, I can combine total lung capacity, which adds all 4 together, vital capacity, which is all the things I have access to, which just simply means the only thing I'm leaving out is the residual volume. And then the next 2 capacities are dividing the lung up at the bottom of a normal breath. What can I breathe in, which is the inspiratory capacity, and what is left over, functional residual capacity. And I hope that makes sense.